Alright, hi there guys. Here's a video for 1.3, the second part to this. We're going to dive right in and talk about how to measure angles. So for the purpose of this lesson, we're going to read about it, take a look at some pictures. The main thing that you guys have to know about this is that we use a tool called a protractor to measure angles. And when we measure angles, they're measured in degrees. So we use a label, degree symbol to label them. So if you take a look at the prior video, we over here we give an example of an acute angle, 12, and we put the degree symbol, which is a little circle on the top right-hand corner. All right, so when we measure angles, there's several ways of doing it, but we're going to talk about the typical way of doing it. Now, for the purpose of this, I'm going to have you guys just imagine and forget about the protractor, which is a tool that we use, and just focus on the red angle. And the main thing you got to know is that this protractor that we have here, the picture, it's lined up in a certain way to measure it. So what we do first is we line up the bottom ray of this angle, this green ray here, line it up with the 0 on the protractor. Now there's two sets of numbers. You have the outside set on the top going counterclockwise, and then we have the inside set of numbers going clockwise from 0 to 180 on both directions. Now those might be confusing, but you can use a tool properly. If you use the tool properly, you can measure the angle, and also you can use your prior knowledge to actually confirm this as well. So you line up the bottom ray, with the 0 at the bottom. So if you take a close look, here's a 0. So we're going to be using the top set of numbers. And you also line up the vertex with the center of the protractor. So center, line it up to 0. And then you take a close look and see where the other ray intersects the protractor. So it intersects at that blue dot I just made, and if you take a close look, and it's kind of blurry, but it lies in between 40 and 50. So the measure of this angle is a 45-degree angle. That makes sense. It's less than 90. It's an acute angle. So that's prior knowledge that we can use to kind of confirm this measurement. All right, so again, there's two sets of measurements. The most important part is to line it up. So let's take a look at another example here. The green angle on the tool, the protractor is, right above it, or you can use to measure it. Again, we line up the bottom ray with the 0. This time we're going to use the inside numbers because the 0 is right there. So we're going to line it up with the 0, and we're going to put the vertex on the center of the protractor. And then we're going to take a look at where it intersects the other ray. So it intersects up here where the blue dot is placed. If you take a close look, you're going this way, clockwise, and it intersects at 110 degrees. Now that makes sense. If we use our prior knowledge, this looks like an obtuse angle, so it has to be bigger than 90. So therefore, this makes sense to be 110. This does not make sense to be, or doesn't make sense if it's 70, because this is an obtuse angle. 70 should be less than 90, and again, wouldn't be that angle. So again, we're using the bottom scale to measure this angle, and this angle is 110 degrees. There's several ways to measuring angles if you have a protractor. You could also just use the difference of the numbers to measure angles. So if you take a close look at what we have here, that protractor is not lined up at 0, but you can still figure it out. So I'm going to focus on the bottom set of numbers, the bottom set. So this ray up on the left side intersects the protractor at 40 if I'm looking at the bottom set of numbers. And if you take a look at the right ray, it intersects in between 160 and 170, so 165. We can use this information and find the difference to find the measurement of this angle. So 165 minus 140 equals 125. So that is the measurement of that angle. Wow, that 5 looks weird. 25. So that's one way. If you take a look at the top set of numbers, the green, the 140 over here, that's where the left ray intersects. And if you take a close look, the ray on the right intersects at 15 in between 10 and 20. So 15. So again, you can find the difference between those two sets of numbers. So difference between 140 and 15 is also 125. So again, several ways to figuring out the measurement. Now moving on to example 5, we're asked to draw an angle. Now, again, if you want to draw an angle, you use the same thought process you did when you measure an angle. So I'm going to use the the top set of numbers to measure this angle 135. All right, so let's say, if you were to measure a 135 degree angle, you would line up the bottom, one of the rays with 0. So let's say you have your ray down here lined up with 0. The vertex is at the center of the protractor. And then you would see where the other ray intersects, and you find 135. So if I'm looking at the top set of numbers, I'm looking for 135. Well, here's 130. So here's 135, this point right there. So I would draw my other ray from the vertex, and then this would be your 135 degree angle. Now you could have done it the other way, and it's fine. Not a big issue if you do it the other way. Let's say your ray down here lines up at 0. Using the bottom set of numbers, 135 is over here. So this would have been your 135 degree angle. It does not matter. Now looking at this example 6, same thing. I'm going to start at the other side now. So let's say again, your bottom ray intersects or lines up with 0. Your vertex is at the center of the protractor. You find 63, so 60 is right there. 63. If I take a look at the markings, that's 65, so a little bit before that. So let's just say there. Draw another ray from the vertex to the intersecting dot, and that would be a 63 degree angle. Could have done it the other way. Again, it does not matter. Moving to the angle addition postulate. Angle addition postulate states if B is on the interior of ADC, then measure of angle ADC equals a measure of angle ADB plus the measure of angle BDC. So here's some new terminology for some of us. M, the symbol, stands for measure of angle, ... So it depends what follows it. That's what you would finish the sentence with. So in this case is measure of angle ADC. So a visual representation of this mathematical statement right there would be what we have over here. I'm going to use some labeling to help us out. Measure of angle ADC, that is the whole thing. That's a big angle. Because technically there's 3 sets of angles in this image right here. You got the big one, ADC. You got one of the small ones inside, ADB, which is this top one over here. And then you have the other small one, BDC, which is this one down here. So three sets of angles in that visual. So what this is saying is pretty much, and I like to call this small chunk plus small chunk equals big chunk. So small angle green plus small angle blue equals bigger angle purple. So that is what the angle addition postulate states. If we were to have numbers to it, we would say 10 plus 20 equals 30, right? If a small angle is added to another small angle, it should give you the whole thing. So let's take a look at example 7. Again, similar to what the definition was, we're asked to find the measure of angle QRT. So we know that one of the small angles is QRS, which is 15. The other small angle, SRT, is 30. So that should equal the bigger angle, which turns out to be 245, which is our bigger chunk. So again, small chunk plus small chunk equals big chunk. Now, sometimes you might be given the big chunk in one of the small chunks. You're going to be asked to find the other small chunk. So example 8 says, what is the measurement of angle LMN if measurement of angle LMO is 85 and measurement of angle NMO is 53. So I labeled it beforehand. If you take a look, again, the red is the whole thing. Measurement of angle LMO, L to M to O, that's the whole thing, that's 85. And then the other piece that was given to us is that NMO, N to M to O, is 53. So we got to find LMN, which is the other small chunk. So you could use algebra to figure this out. We can say X, which we don't know, plus 53, which is one of the small chunks, is equal to the big chunk, or the whole thing, which is given to us, is 85. So using a little bit of algebra, we can figure this out. We can say, all right, well, if I subtract 53 to both sides, then I know the measurement of LMN, which is 32 degrees. So this has to be 32, so that both the small angles add up to 85. Now we're going to run into some of the little algebra here, so please bear with me. Example 9 states that if measurement of angle GFN, which is small angle here, I labeled it, and measurement of angle NFE, which is the other small angle here, I labeled it, blue, is equal to the whole thing. Sorry, not. And that angle, measurement of angle GFE is 157, which is the whole thing. GFE is 157. So we're asked to solve for x. Now, using the angle addition postulate, we can write an equation. Again, small chunk plus small chunk equals big chunk. My small chunk, or my two small chunks, are the green and blue, GFN and NFE. Added together should be equal to our big chunk, which is 157. So here's my equation here. I know we have a fraction. We'll deal with that in a bit. So that's my equation. Let's start off with the simple things here, combining like terms, the 10 and the 3. We are left with 4x plus 12 over 7x equal plus 13 equals 157. Now before we get into dealing with the fraction, let's just move the 13 over by subtracting 13 to both sides. So we are left with 4x plus 12 over x plus 7. That's going to equal now 144. Now how to deal with this fraction? There's several ways. We could get a like denominator and figure out what that is. But one way to actually get rid of fractions and manipulate this equation is by actually multiplying the whole thing by the denominator that we have, which is 7. So by multiplying this whole equation, we're actually going to get rid of it. Get rid of that denominator 7. So 7 times 4 is 28x. And here's the most important part, the main reason why we multiply by 7. 7 times 12 over 7 actually gets rid of the denominator. So now we're just left with 12x. And then equal to 1008, because we also have to multiply 144 times 7. Now that looks much simpler. We can solve that. We can say 28 plus 12 is 40x now, equals 1008. Divide both sides by 40. X equals, if I remember correctly, that was 25.2. We solved for x. Alright, finally we have example 10. It says, if measure of angle ABD is 9x minus 37, find the following. We have 3 sets of things we need to find. We need to find x, we need to find measure of ABC, and measure of angle CBD. So again, if ABD is 9x minus 37, ABD, that is the whole thing. That's a big chunk, right? We're given the small chunks inside of this image, so there and there. We can come up with an equation to, first of all, find x. Because if you want to find the measurements of the other angles, we need to know what x is first. So, again, small chunk green plus small chunk blue equals big chunk red. That's our equation. Once you have your equation written, we can combine like terms and then solve this. So we're combining like terms on one side of the equal side. So 4x plus 3, that's 7x. And then 2 minus 7, that is negative 5. And we're going to bring everything on the right side down. So 9x minus 37. Now, because I want to subtract the smaller x over to the other side so we can keep positive numbers, I'm going to subtract the 7x to both sides. So we're left with negative 5 equals 2x minus 37. And then I'm going to add 37 to both sides. This is going to be 2x equals 32. Divide by 2. X equals 16. So we figured out what x is. X equals 16. Now we know that piece of information. We're asked to find out what angle ABC is, which is the green angle I highlighted on the picture over here. So we can use x to figure that out. So measurement of angle ABC equals 4x plus 2 So we know what x is. X is 16. That's what we found out. So we can get our calculator if you need it and figure out what this is. So measurement of angle ABC. 4 times 16 is 64. 64 plus 2 is 66. So measurement of angle ABC is 66 degrees. And now we could do the same thing for measurement of angle CBD, which is the blue that I highlighted on the image. It's a similar thing. measurement of angle CBD equals 3x minus 7. Again, we find out what x was. So 3 times a number minus 7. And that number was 16. So 3 times 16 is 48. So measure of angle CBD is 48 minus 7, which is 41 degrees.